Welcome everyone. In this video, we are breaking down a key idea in additional mathematics, the definition of a function. By the end of this video, you will know how to identify functions from mappings, calculate ranges, and tackle exam-style questions. Before we dive in, make sure you are comfortable with evaluating simple functions. If f of x is equal to 5x minus 1, find f of 3. It means we have to take the value of x as 3 and in place of x, we will substitute 3 and then we will simplify. So 5 3s are 15 and 15 minus 1 is 14. A function is a rule that maps each x value to just one value for a defined input values. No input can be linked to more than one output. That's what makes it a function. This means that mappings that are either one-to-one or many-to-one are called functions. The mapping x to x plus 1, where x belongs to real numbers, is a one-to-one function. It can be written as f of x such that x plus 1, x belongs to real number. Or it can be written in this form as well. You must know both the ways of writing this function, because sometimes it will be given in this form and sometimes in this form. And we read it as the function of f such that x is mapped to x plus 1. Let's do some examples. We have f of x is equal to 2x plus 3, or function of f such that x is mapped to 2x plus 3. And g of x is equal to x squared minus 5. We have to find the values which are given here. This f or g represents the name of the function. It can be either f of x, it can be g of x, it can be h of x. Usually, the functions are represented by these three letters f, g, and h. If we have to find out f of 1, it means that in function f, we have to substitute the value of x as 1. So we have here f of x is equal to 2x plus 3. So in place of x, we will substitute 1 here, which is equal to 5. F of 4 means that in function f, we have to substitute 4. 2 4s are 8. 8 plus 3 is equal to 11. G of 3. G of 3 means we have to substitute 3 in function g. So we have here x squared. So we will substitute 3 in place of x and we will put square on it. Minus 5 is equal to 3 squared is 9 and 9 minus 5 is 4. F of k means that we have to substitute k in place of x. So 2 into k plus 3. As there is a variable, so we cannot solve it. We can simply write it as 2k plus 3. G of t minus 1 means we have to substitute t minus 1 in place of this x. So we will write t minus 1 in bracket, we put square on it, then minus 5. We can simplify it by using identity. So when we will expand it using identity, we will get t square minus 2t plus 1. Minus 5 is already there, so we can write here minus 5, which is equal to t square minus 2t minus 4. Now we will discuss about domain and range. Domain are the input values, or you can say values of x. So whenever it says domain of the function, it means that the values of x which we use for that particular function. In this case, for function f, the values of x which we have taken are 1, 4, and k. So this is the domain of function f for this particular question. For g of x, we have used here 3 and t minus 1. Now what is range? Range are the output values. Whatever the result we get after substituting the value of x is the output. Or we can say these are values of y. We can write function as y is equal to 2x plus 3 as well. So it's the same, it's a function of x. Range is also called image set. In this case, 5, 11, 2k plus 3 are the values in the image set for the function f. 4 and t square minus 2t minus 4 are the values of y in the image set for function g. In the last video, we did mappings. Now, we'll see which of the mappings are functions. Whenever we have to check that whether the mapping is a function or not, we do vertical line test. We draw vertical lines at different points. If the line intersects the graph at one point, it means it is a function. A vertical line is intersecting the graph at one point, so it is one-to-one mapping, and it is a function. Now we have another question in which x is mapped to x squared plus 2 and x belongs to real number. So we'll do the same. We will do vertical line test. We will draw vertical lines at different points. So these vertical lines are intersecting this curve at one point. So it means that it is a function. For two inputs, there is one output. So it's many to one mapping. it is also a function. One-to-one and many-to-one are function. Let's see this one where x is mapped to x cube. It is a cubic function and x belongs to real number. We will do a vertical line test. We will draw vertical lines at different points. You can see these vertical lines intersect at one point. So it means it is a function. And for each input value, there is one output value. So it's one-to-one and it is a function. Let's do this one where x map to 2 power x, it's an exponential function where x belongs to real numbers. All real numbers are included. So let's draw vertical lines at different points. If we'll draw a vertical line here, it is intersecting this curve at one point. If we'll draw a vertical line here, it is intersecting this curve at one point. Here as well, it is intersecting at one point. Here as well, it is intersecting at one point. For one input value, there is one output value. So it is one-to-one mapping and it is a function. It is one-to-one function because vertical lines are intersecting the curve at just one. Let's do another one in which x is mapped to 1 upon x. It is a reciprocal function. X belongs to real number and x is greater than 0. It means that we have to consider the graph or the values of x which are greater than 0. We have to first check which mapping it is. Either it is one-to-one, one-to-many, or many-to-one. So we can see for one input, there is just one output. So it is one-to-one. And then we will draw vertical lines at different points. At this point, it is intersecting at one point. Here as well, it is intersecting at one point. Here as well, it is intersecting at one point. So it is a function. Let's do another one in which x is mapped to x squared plus 1. It is a quadratic function. X belongs to real number and the domain is x is greater than or equal to 0. It means that we just have to consider the part where the values of x are greater than 0. We don't have to consider this part of the curve. For this part of the curve, it is one-to-one mapping. Now we have to check whether it is a function or not by vertical line test. We will draw vertical lines at different points. The lines are intersecting this curve at one point, so it is function. In this part, x is mapped to 12 upon x. It is also a reciprocal function. X belongs to real number and x is greater than 0. It means that we just have to consider the values of x which are greater than 0. As we know, it is one-to-one mapping. One-to-one mapping is a function We can also check by just drawing the vertical lines. So vertical lines are intersecting this curve at just one point. So it means it is a function. In this case, x is mapped to plus minus x. The graph is already drawn. X belongs to real number and the domain is x is greater than or equal to 0. It means that we just have to consider the part of the curve which is greater than 0. So we have to consider this part of the curve. You can see for one output, there are two outputs. So it's one to many mapping. And one to many is not a function. Either one to one is a function or many to one is a function. One to many is not a function. We can check this by vertical line test as well. We will draw vertical lines at different points. We can see this vertical line is intersecting the curve at two different points. In the same way, we can draw vertical line here as well. You can see the vertical line is intersecting this graph at two different points. So it means that it is one-to-many mapping and it is not a function. Let's do another question in which we have to find the range of functions. The first function which is given is f of x is equal to 7 minus 2x. The domain is given from -1 till 4. So we will substitute -1 here. By substituting -1, we will get here 9. Then we will substitute 4 here. By substituting 4, we will get -1. So we can write range as f of x is greater than or equal to -1 and less than or equal to 9. Here we have to write smaller number and here we have to write the greatest number. We can also write it as y is greater than or equal to -1 and less than or equal to 9. How do we decide about the sign? Whether we have to put here less than or equal to, same is the case over here as well. We have got 9 as output when the input is -1. Then we see if this -1 is included in the domain, then we have to include this 9 as well in the range. So that's why we have put here this sign. In the same way, when -1 is output, input value is 4, which is there in the domain. So -1 is also to be in the range. So make sure when you are writing this range, then you have to check it whether it is there in the domain or not. F of x is equal to x squared. We will be substituting in place of f -3. So -3 squared is 9. F of 3 is 3 squared. So it is also 9. Now, how we'll write range in this case? We can see here this function is quadratic function. So whenever we have quadratic function, then we get a curve, a symmetrical curve. And in this case, the curve is simply like this. So whenever there is quadratic function, then we have to check the turning point as well. When input is -3, output is 9. When input is 3, then also output is 9. And we have to consider the turning point as well. So the turning point here is 0, 0. Now, when we will be writing range, we have to consider the value of turning point as well, as the value of x is there within this domain. 0 is there within this domain. We have -3, -2, -1, 0, 1, 2, 3. So this 0 is also there in the domain. So we will consider its y value as well. We will write range here. F of x is greater than or equal to 0. The smallest value is 0. And the largest value is 9. At -3, it is 9. And at 3 as well, it is 9. The greatest value of y is 9. And the smallest value of y is 0. So the range is from 0 till 9. And we have got 0 when there is value of x is 0. So x is 0 is there in the domain. So this is also to be a part of domain. So that's why we have written here the sign greater than. In the same way, 9 we have got when 3 is the input. 3 is there in the domain. So that's why 9 is also to be a part of range. So we have put here the sign less than. In this case, f of x is equal to 2 power x. It's an exponential function. And the range is given from -3 till 3. When we will substitute here -3, then it is 2 power -3, which is 1 upon 8. F of 3 is 2 power 3, which is equal to 8. So when we will write the range, f of x is greater than or equal to 1 upon 8 and less than or equal to 8. -3 is there in the domain. So 1 upon 8 is also to be a part of the range. 3 is also in the domain. 8 is to be a part of the range. Here, f of x is equal to 1 upon x. It is a reciprocal function. When we'll substitute 1 here, it is equal to 1 upon 1, which is 1. Another value, we have to substitute 5 here. So it is 1 upon 5. So the range is f of x is greater than or equal to 1 upon 5 and less than or equal to 1. 1 is there in the domain. So that's why this one is included in the range. This 5 is in the domain as it is less than or equal to. So 1 upon 5 is also to be there in the range. Let's do another question in which the function is defined by f of x is equal to 10 minus x minus 3 whole square for x is greater than or equal to 2 and less than or equal to 7. Sketch the graph of the function and find the range. So first of all, we will sketch the graph. We can just substitute 2 and 7 to find out the values of y. F of 2 is equal to 10 minus 2 minus 3 whole square. So it would be 10 minus 1. 2 minus 3 is minus 1. Minus 1 square is 1. So we have 9 here. So it means at 2 there is 9. Then f of 7 is equal to 10 minus 7 minus 3 whole square. So 10 minus 7 minus 3 is 4. 4 squared is 16. So we can write here 10 minus 16, which is equal to minus 6. So we have here 7 comma minus 6. As it is a quadratic function, so we have to consider the turning point as well. We have here 10 minus x minus 3 whole square. The smallest value which we can consider for this is 0 because there is a square. If you will get here negative, it will always be positive. So if we take x minus 3 is equal to 0, it means the value of x here is 3. And for this value of x, the value of y is 10. So we have another point that is 3 comma 10, which is also a turning point. We can mark these points on the grid and then we can sketch the curve. We can take here 2, 4, 6, 8, 10. In the same way, we can mark here -2, -4, and -6. We can mark here 2, 4, 6, 8, 10. At 2, there is 9, which can be here. At 3, it is 10, which is here, and it is also a turning point. And then 7 comma -6, which is to be here. So we can sketch a curve like this. This point, 3 comma 10, is turning point. This minus sign indicates that the curve is a maximum curve. Now we have to write down the range. So we'll see the greatest value of y and the smallest value of y. So the smallest value of y is -6. So the range will start from -6 till 10. -6 till 10. Another question, the function f is defined by f of x is equal to 3 plus under root x minus 2. For x is greater than or equal to 2, find the range of f. In this case, we will substitute the value of x as 2. So when we will substitute x as 2, this part will become 0. So it is equal to 3. So we can write down the range as f of x is greater than or equal to 3, as the domain is x is greater than or equal to 2. So the range is f of x is greater than or equal to 3. Let's do some past paper questions. The function f is defined for the domain x is greater than or equal to -3 and less than or equal to 3 by f of x is equal to 9x minus 1 upon 3 whole square minus 11. As we know, this is a quadratic function, so we have to consider the turning point as well. We can easily take out turning point by equating x minus 1 upon 3 to 0. So x is equal to 1 upon 3. And when we will substitute 1 upon 3 over here, 1 upon 3 minus 1 upon 3 will be 0. So we'll be left with minus 11. So the turning point is 1 upon 3 comma minus 11. Now we will substitute the value of x as minus 3. 9 into minus 3 minus 1 upon 3 whole square minus 11. So when we will simplify, we will get 100 upon 9 here. So 9 and 9 would be cancelled out, so we will be left with 89. 100 minus 11 is 89. Then we will substitute 3 here. 9 into 3 minus 1 upon 3 whole square minus 11. So when you will simplify it, you will get 64 upon 9 minus 11. So 9 and 9 would be cancelled out and you will be left with 53 here. At 1 upon 3, there is minus 11. At minus 3, it is 89. And at 3, it is 53. So the range would be f of x is greater than or equal to minus 11 and less than or equal to 89. Why we have considered here this turning point? The value of x at turning point is 1 upon 3, which is there in the domain. So that's why we have to consider this minus 11 within the range, and minus 11 is the smallest of all three values. So that's why we have written here minus 11. Let's do another past paper question in which we have to write down the letter of each graph which does not represent a function. To find out whether the graph represents a function or not, we have to do vertical line test. So when we will draw vertical lines here, the vertical lines are intersecting at 2 points. So it is not a function because it is one-to-many mapping. We will draw vertical lines here. We can see the vertical lines are intersecting the graph at just 1 point. So it is a function. Same is the case here. We will draw vertical lines. So the vertical lines are intersecting the graph at 1 point. It is also a function. Same we can do here. Vertical lines are intersecting the graph at 1 point. So it is also a function. We can see here the vertical lines are intersecting the graph at 2 points. So this is not a function. We will draw vertical lines in this as well. The vertical lines are intersecting at one point. So it is also a function. We have to write down the letter of each graph which does not represent a function. So A and E are the graphs which does not represent a function. A quick recap. A function is a rule that maps each x value to one y value for a defined input values. Mappings that are either one-to-one or many-to-one are called functions. The set of input values for a function is called the domain of the function, and the set of output values for a function is called the range or image set of the function. Now you know how to identify functions and find ranges. Keep practicing to sharpen your skills. Hit like if this helped you. Share with friends and don't forget to subscribe to Samathics for more AdMath tricks and tutorials. Until next time, keep solving.